Recording in progress.
Hi, I'm Dorothy, and I'll be explaining question 7 of chemical kinetics. The question states, a student fits concentration data 3 ways and obtains the following lines. The first, the concentration of A versus T, where Y equals negative 0.0180 T plus 0.900 with an R squared value of 0.912. The second, the natural log of the concentration A versus T, where Y equals negative 0.0450 T minus 0.105 with an R squared value of 0.9996. And finally, we have 1 over the concentration A versus T, where Y equals 0.0820 T plus 1.11 with an R squared value of 0.930. Part A asks, what is the reaction order? And to determine this, let's first identify the reaction orders of the lines provided. Above, in the first one, where we have just the concentration A on the y-axis versus T time on the x-axis, this tells us that it is a zero-order reaction. In zero-order reactions, their rates are not dependent on their concentration. So the concentration does not influence the rate at which the reaction occurs. The second line, we have the natural log of the concentration A versus T. And when we have the natural log of a concentration on the y-axis, this tells us that it is a first-order reaction. And finally, we have 1 over the concentration. And when we have 1 over the concentration on the y-axis, this tells us that it is a second-order reaction. First and second-order reaction rates are dependent on their concentrations. So changing the concentration will change the rate at which the reaction occurs. Now let's look at the R squared values to answer A. R squared provides us with the line of best fit. The line that's most linear is the line that will determine our reaction order. And between the 3 lines given, we see that the first order reaction with an R squared value of 0.9996 gives us the most linear line. And so we can determine that this is a first order reaction. And just to reiterate, this is because that given this graph of the natural log concentration A versus T, the 0.9996 R squared value is going to give us the line of best fit between these 3 lines. And part B asks, what is K? So we're going to be using the first order reaction above from here on out. And let's use the integrated rate law for a first order reaction. That states that the concentration at a given time equals negative K, so the rate constant times T, time, plus the natural log of the initial concentration. Now let's plug in the values above to determine what K is. So the concentration at a given time equals negative 0.0450, and the units for a first order reaction rate constant is S inverse times T plus the natural log of negative 0.105. And we can see that our given equation has a negative value, and the rate law for a first order reaction has a negative K value. So we can determine that K just equals 0.0450 seconds inverse. And part C asks, what is the initial concentration? So from the first order reaction rate law, we have that the concentration at a given time equals negative K times T plus the natural log of the initial concentration. And to solve for just the initial concentration, we take E raised to that value. So for us, we have a value of negative 0.105, and e to the negative 0.105 gives us a value of about 0.900 molar. So our initial concentration is equal to 0.900 molar. Part A, this is a first order reaction because in this graph, this gives us the line of best fit, which is the first order reaction from above, and K equals 0.0450 seconds inverse, and the initial concentration is 0.900 molar. Thank you.